Hello, everyone, and welcome back to another episode of Kelly Telly. Today, I'm going to be just making a short video going over the basics of waves. In front of you right now, you can see what happens when white light enters into a prism, and what we call, or we're going to work out what it is called a little bit later. But it is basically splitting into the different colors of the rainbow that we know. But I'm going to go over the basics of some waves, basically amplitude and frequency, and then we're going to look at how to draw those different types of waves, which was some work that I gave you a little bit earlier last week. So let's have a look. All right, amplitude and frequency. So we are going to look at amplitude first. And amplitude refers to, actually I'll pull up the little definition here. Amplitude refers to the strength of a wave. So if this is our starting point of the wave, the amplitude is the distance from this origin line in the middle here to the highest part of the crest of a wave. And the crest is obviously the top part there. So in this example of a wave here, this distance from here to here, this distance here is called the amplitude, and it should be the same on both sides of the wave. I didn't draw it perfect there, but basically the amplitude, call it A, should be the same for each crest of the wave and each trough as well, which is these bottom ones. So we call this one up here a crest, and we call this one down here a trough. Now that is amplitude. Basically, it's the strength of a wave. Now, basically, the higher the amplitude, it can have different. The strength of the wave, if it is a light wave, it'll be a brighter light. If it's a sound wave, it'll be a louder sound. Okay, so I'm going to erase that, and we're going to get rid of that. And we're going to talk about frequency now. So frequency, as you can see down the bottom there, is refers to how many waves are in the same time frame. Okay, so if we have a wave that's like this, all right, so that is one single wave. So where it goes up to the peak, and then down to a trough, and then back to its starting point. So we call that, this here, that is one unit. Okay, so that's just one wave, right? We just call it one wave, that's easier. One wave. Now, if this from here to here was 1 second as well, we would say that its frequency is one wave per second. Pretty easy, right? Now, if we change the length of the wave, the frequency that is, this is obviously not going to be the best the best wave, but let's go. Oh. And okay, that's pretty poor. But okay, so let's pretend that's not 1 second. Let's pretend 1 second is here. Now, the frequency of this wave, obviously it is not perfect by any stretch, but we have some repeating waves here. So what we need to do is we need to count how many waves occur in the 1 second time frame. So we've got one wave there because it's back at the same point. We've got another wave here. So it's another wave there. It is another wave here. And waves change in amplitude and frequency, so you need to be able to do this. That's 4, and that is 5. So we have 1, 2, 3, 4, and 5. So the frequency for this wave would be 5 waves per second. Okay? I hope that that makes sense in terms of frequency and amplitude. Now, we're going to go over on the next slide now some examples of drawing these that I asked you to do last week, and some people had some trouble. So hopefully this will help clear it up. Okay, so first example we're going to look at here is if something has a low frequency and a high amplitude. So let's break this down first. So low frequency means that there would be less waves in the same time frame. Okay, so right here we've got less waves. So less waves, and low amplitude means that the waves are not very strong, which means that they are not far from the origin. So a wave that came up to here would be up to here would be quite strong, and a wave that was only up to here would have be a little bit less so. Now, with this in mind, how would we draw out a low frequency, low amplitude wave? Well, it would be like this. It would have a low, so we're going to draw, I'm going to just do one wave because that's as low as frequency as you can have, one single wave. And I'm also going to do it with a low amplitude, so I'm not going to draw beyond this point or beyond this point on the graph. So I'm going to go like this, and then like that. As you can see here, this is one wave, so it has a low frequency, and it has a low amplitude. The amplitude is very small compared to what we could draw. Okay, so that's the first example there. That's low frequency, low amplitude. All right, the second one is low frequency, high amplitude. So we're going to do the same amount of frequency, like one wave, but this time we're going to do high amplitude. So what's the difference there? It is the difference from this origin point. So I'm just going to do that quickly, like this and like this. That would be a low frequency, high amplitude wave. Again, low frequency because there's only one wave, and high amplitude because there is a greater distance from the origin line there. All right, let's look at two more. The first one is high frequency. So instead of less waves, this time we're going to look for more waves. Okay. So with this one, we're going to look for more waves. So let's just say we'll try and fit 4 or 5. And a low amplitude. Again, it is this low amplitude, so it's not far from the origin line. So let's give it another go. So this one's probably going to be a bit like this, and like that, and like that. Oh, I'm not sure if I'll fit in the last one. I got a little bit weird at the end there, but you can see that there is 1, 2, 3, 4, 5. 5 waves in there. They are all low amplitude and at a very high frequency. So the frequency, think of the normal word frequency, the amount of times. The amount of times these waves appear is higher. Okay, so it's high frequency, low amplitude. So the last one is going to be high frequency and high amplitude. So high frequency is going to be multiple waves, same as this one, and high amplitude is going to be like this one, nice and big waves there. So let's try and do that like so. And this one here is going to be a high frequency, high amplitude. So we can see that the waves go a fair distance from the origin line in comparison to the other ones with the low amplitude. And also there's a high frequency. So we have at least 1, 2, 3, 4, 5 of these waves as well. So this is how we draw out the different, these are transverse waves. We're going to talk about the longitudinal waves a little bit later, but this is basically how you would go about drawing these. Now, how does this relate? So sound actually is produced in longitudinal waves, but sometimes just to wrap our head around it, we use these diagrams. So to explain sound in terms of these, we need to think what frequency and amplitude means for sound. So amplitude for sound means it is a louder sound. If it's higher or if it's a lower sound, then if it's a lower amplitude, then it is a quieter sound. Frequency, if it's low, it means it is low pitch. And if it is high frequency, it means it is very high pitch. So you also need to be able to describe the type of sound produced from certain waves, given the information we have here. So for example, looking at B here, if we had this and this was representing a sound wave and it had low frequency, high amplitude, it would mean that it would be a very loud, low sounding note. Whereas this one down here, C, would be low amplitude again, so it'd be quiet. This one would be quiet, and would have a high frequency, so it'd be a very high pitched but quiet sound. So this is an example of the different types of waves. I hope that cleared up a little bit, and I will see you guys in the next video.